Hey everyone, in this video I have a geometry problem for you that in practice can be solved by very basic high school geometry knowledge but still took me one whole night to solve. So we have a square with each of its sides being 1 unit. Using 4 of its corners as center, 4 circular arcs were drawn as you can see in the diagram. Your task is to find the area of the segment that is covered by the orange color. If you want to solve it by yourself, pause the video and think about it for as long as you want. I am going to solve it now. So firstly, the area of the square, which I denoted here with A of S, is equal to 1 square, which is equal to 1. And the area of this red circular segment, which is 1/4 of the area of the circle, is equal to pi r square over 4, which is equal to pi over 4 because r is equal to 1. Now what about the area of this green section right over here? Well, this section is nothing other than the difference between the area of the square and the area of the red circular segment. Let me denote the area of this green section by A. So A is equal to area of the square minus area of the circular segment, which is equal to 1 minus pi over 4. Now what about the area of this green section right over here? Well, we can find the area of this segment if we subtract the area of these two green segments from the area of the square. The area of both of these green segments are same. Why? Well, I will leave it as an exercise for you to figure out. Now if we denote the area of the green segment with B, then we have B is equal to pi over 2 minus 1. Now this orange segment consists of these 3 subsegments right over there. Let me denote the area of this segment in the middle with X. This is what we want to find. And let me denote the area of each of the segments on the side with Y. This gives us the equation B equal to X plus 2Y. If we plug in the value of B, we get this equation of X in terms of Y. Now let's have a look at this green segment, which we denoted by A. This green segment also consists of 3 subsegments. We already denoted the segment in the middle with Y. Let's denote the segments on the side with Z. This gives us the equation A equal to Y plus 2Z. If we plug in the value of A here, we get this new equation. If we substitute this value of Y in our previous equation of X, we get this equation of X in terms of Z. So the value of X, which is what you want to find, depends on the value of Z in this equation. The question is how to find the value of Z. So far everything I did was very straightforward, but this is the critical part of the exercise. This is where I was stuck for a while. I didn't know how to find the value of Z. Then after some time I found this beautiful idea of connecting the dots. You see, if you connect these 3 dots, you get a triangle. But this is not just a random triangle. This is actually an equilateral triangle with all of its sides being 1 unit. Why 1 unit? Well, the base of this triangle is basically the side of the square, which is equal to 1. The other 2 sides is equal to the radius of the circular segment, which is also equal to 1 unit. That means the area of the triangle is equal to root over 3 over 4 a square, which is equal to root over 3 over 4. On the other hand, the area of each of these blue circular segments is 1/12 of the area of the whole circle. Why? Well, the angle they make at the center of the circle is 30 degree, which is 1/12 of 360 degree. As the area of the whole circle is pi, the area of each of these blue segments is pi over 12. Now we make this simple observation that if we combine the area of the equilateral triangle along with the area of these 2 blue segments and the segment which we denoted by Z, we have the area of the whole square. From this equation, it is very easy to find the value of Z, which when we plug back into our previous equation gives us the value of our desired X. Numerically, X equal to 0.315 unit. This is the area of the orange segment. There you go. This is our solution.